Okay, and so now for problem number 11 on the 10B, which was 7 on the 12B. In the figure below, WXYZ is a rectangle with WX equal to 4, not labeled, WZ equal to 8. Go ahead and label it. Point M lies on XY. Identify it as you're reading. Point A lies on YZ, and angle WMA is a right angle. Those are all marked for you. The areas of triangles WXM, this one, and WAZ, this one, are equal. What is the area of triangle WMA? So my suspicion is that you can solve this by calling this like X, and you could put Y up here if you wanted. I'm going to put it here for reasons I'll get to later. I don't actually know why. It's what I did in my problem when I solved it. This is just the way I solved it. You might have found a quicker way again. Not all my solutions are most efficient. So I called this 4 minus Y. Now, again, I probably could have called that Y and this 4 minus Y, and maybe it's better, but that's not what I did. So anyhow, what you could do here, I bet you could just do Pythagorean. For instance, this will be 8 minus x, and I bet if you do this squared plus that squared square rooted, and then this squared plus that squared square rooted, and you did something with that, I bet you could find the area, without having to actually find x and y is my suspicion, but that's not what I did. I went ahead and you could explore it for yourself and see. I just went ahead and set the base and height x times 4 and this times that must be equal. So 4x has to equal 8 times 4 minus y. And so you get 4x equals 32 minus 8y. Probably should have just divided by 4 first. That would have been smarter. X equals 8 minus 2y. So x plus 2y equals 8. So now I just said, well, this whole thing's 4 and that looks bigger than half. What if I just guessed that this was 3? And that's what I did. You could do other things, I suppose. I could probably replace the x and the y and do a bunch of algebra. But sometimes you take gambles just to see if it works out. And that's what I did. I said x2, y3. That does make 8. Let's see if it works out. I'm going to replace this with a 2. This would then become a 6. This would be a 3. This would be a 1. Then square 8 squared plus 1 squared is root 65. That's your hypotenuse. 16 and 4 is root 20. 36 and 9 is root 45. So the deal is that's a root 45. I'll write nicer, maybe a little bit nicer. Okay, so root 45. That squared plus that squared equals that squared. That's exactly what we needed to happen. Would it have worked for other values? Maybe. Explore the problem yourself and see. Did I get lucky? I don't know. I suspect that it doesn't maybe matter what the values are specifically as long as that was true. Maybe I'm wrong. Find out. I don't know. But it worked out. And as long as it works out, we don't care. That's the thing. You don't have a limited time. You don't have time to prove every possible way to solve it while you're solving. And I certainly didn't wish to establish whether or not multiple values could be used. But let me know in the comments if you found another way. That'll help other people out. So then what now? It wants to know the area of this triangle, which is simply going to be root 20, which is root 5 times 2, times root 5 times 9, root 9, and then that's going to be 3 times 2 is 6 times 5 is 30, and then you'll divide that by 2 to get answer choice C, which is 15. So basically the root 20 is root 4 times root 5. I saw the 2. Here I was trying to make it the right way, but I just didn't. I wrote it the wrong way. I should have written 3. So 3 times root 5, and so 3 times 2, 6. Root 5's multiplied gives you a 5. 6 times 5, 30. Why are we dividing by 2? Half base times height. I'm sure you'll understand that's why the answer is C. Let's get to the next problem. Continuing on the rapid fire video with problem 12 from the 2024 10B. A group of 100 students from different countries meet at a mathematics competition. Each student speaks the same number of languages, and for every pair of students A and B, the two students in general, not specifically, There's not like we don't have to label all of them A, B, C, D, just any two, okay? Student A speaks some language that student B does not speak, and student B speaks some language that student A does not speak. What is the least possible total number of languages spoken by all of the students? So this problem, it takes a little bit of time to process. That's why I read it slow. What it is they're saying. What are you supposed to use as a strategy? How should you go? What does this mean that one B speaks one that A doesn't speak, A speaks one B doesn't speak? But once you realize, once you start going through your thought processes of what tools might you use, when you realize the right one, it cleans up pretty fast. I think the start, you might spend a couple minutes kind of just poking around with some things before it finally clicks for you, or you might give up before that point, and I hope not. It really isn't that bad once you realize what they're saying. First, another point to make too, this might have been harder for some people who had a language barrier, because you might not understand what this last sentence means. I mean, it can be a little bit of a nuance. Even domestic English speakers, or like native English speakers, if you will, could possibly have trouble with this. I've had students in the past that would probably have trouble with this past sentence. And the question you want to ask yourself is it asking for the number of languages per student? Like the total number of languages per student spoken? Because they each speak the same number. Or is it of all the students, all of the different languages combined total? And I think I could easily see how a lot of people might have trouble with that. But what they're saying, if you can understand it, is just the total languages spoken by all the people. Not if like each person spoke 5, the answer is 5. That's not what it is. It's the total out of all 100. If I took every single one and grouped them up, counting each language one time, what would the total be? And so once you realize that, but be sure, even I kind of made sure that's what I was looking at, okay? Then you say, all right, well, what does this mean that A will speak one that B doesn't speak and vice versa? And you kind of go, gosh, I wasn't even almost quite sure where to begin myself. And then you think, well, let's look at the answers and see if they give us any ideas. These ones are kind of close. Let's say it was 10. Just what if? What if? This is a game I like to play on the test, and you should play it as well. I call it what if. And you just ask, what if this was true? What would happen? Right? You're kind of trying to form some kind of a hypothesis, what happens when. And so you say, okay, if there was 10 languages, how would I distribute them? Well, you'll say 100 students, 10 countries. How can I be sure? Ooh, maybe combinations. If I did something like 10 choose 3 languages for each person, could I be sure how many ways can I choose 3 languages? If it's over 100, then we're good. If each person spoke 3 languages, for instance. And you say, but how can I be sure that this criteria is met? And you should ask that. Even me, I asked myself that, but I could quickly render that when you're doing combinations, there's no duplicates. Your only concern would be if it was 3 languages, if 2 people had the exact same 3 letters, okay? And can that happen with combinations? No. Every choice of 3 letters will be unique. And that's how combinations works. And so once you realize that, you go, oh, I could just guess and check till I get it. Let's see if 10 works, for instance. And so you say 10, 9, 8. I mean, the maximum you're going to get is probably 10 choose 5, right? So if I did 10 choose 5, you'll have 7 and 6, and then the denominator will be 5 times 2 and 4 times 3. I guess I'll put the 3 here. Okay, so 5 and 2 cancels the 10, 3 cancels the 9 to make 3, 4 goes into 8 twice. 6 times 6 times 7 is 36 times 7. So 210 and 42 is 252. That's a lot more than 100. That makes me wonder. First off, we found this, and we did want least possible. That was one of the things that I suggested you might get a lot of. on the Monday video. But if you go, well, what if 10 works, could 9? Why don't we find out? 9 choose 4. By the way, when you're doing these calculations, that number, as long as it's as low as, if I was comparing between these two, they're equal. Pick the one that's equal that has the smaller number. That's the number of terms you write in the numerator. So if you're doing these quick, it's 9, 8, 7, 6, and then you just turn this into 4. Why those 4? Because you write 4. It will always match that number. Would it match 5 numbers? No, it would actually be 4 numbers as well, which is why when you have 2 equal ones, choose the one that's the smaller number in the bottom. Okay, so 9, 8, 7, 6, and then you're going to write 4, 3, 2, 1. I like to line mine up, so I guess I'll put like 3 and 2 and 4 here, and I'll cancel the 6 and give myself a 2, and I've got 14 times 9. So 14 times 9 is 14 times 10 minus 1. 140 minus 14 is 126. Now, you are already still over 100, and that means the answer is A. Now, even though I got this and concluded it, I still wanted to go back and challenge one more time. The problem does make you feel a little bit uncomfortable. If you're not challenging your thinking, if you're just going, nope, I'm super smart, I don't make mistakes, then you're going to make mistakes. You have to understand that you're going to, if you made a mistake, you wouldn't catch it. Your brain fills in some illogical thought that you think is logical in the moment, otherwise you wouldn't keep going with it. So you really have to go back and second guess yourself. And I did. I spent probably, am I really sure? Because it was the lowest one and they're all higher. Do they really do that? It's just this 9 down here. You just had to do this. Am I certain? I'm not missing any detail. If I did 9 choose 4, all 4 of them are definitely different. There's no duplications of the 4 letters. Man, I guess that's it. And you really have to kind of do that, and then you feel comfortable with it, and you move on to the next one, which is what we're going to do right now. Continuing on with problem 13, positive integers x and y. Now this is another problem that there's multiple paths you might take, and you might have taken several that were not good, and they end up being time drains. And so if that happened, it did happen to me. It depends. If you thought of the best way right from the start, then you probably saved some time. This is kind of one of those things where people who tried one of 3 paths and picked the right door, you know, then they're like, they get ahead, and that's how that goes. And you might burn 5, 6, 7, 8 minutes on this problem doing valid things that don't work out. And that's part of the difficulty of the test, is knowing when to skip or what should I do with a problem like this. So positive integers x and y satisfy this equation. Now I got square root of x plus root y equals that. My immediate thought is to square both sides. It just looks like what you're supposed to do, I mean, unless you want to work with square roots. What is the minimum possible value of x plus y? So I thought about maybe calling this a and this b, and then this would be a squared plus b squared, and that might work as well. But for starters, let's just see how I developed originally. I went ahead and squared both sides. You're going to get x plus y plus 2 root xy equals 1183. And you say, oh, well, what do I do with that? And I thought, well, maybe I'm looking for x plus y. Maybe I should keep it together. So if I move this over here and I take this one and move it to the other side, then I'll have x plus y squared minus 1183 equals negative 2 rad xy. Now this is not the path that ends up working. I'm just kind of showing you things you might have thought of doing or trying. And so you say, okay, well, I guess I have to square again. And so because, wait, not squared yet, sorry. It's just x plus y minus. We're about to square, and so it's going to become squared when you do that. So now what I have is this minus that pulled over, and we're going to square both sides. So you're going to get 4xy over here. Here you're going to get x squared plus 2xy plus y squared minus 2200, 2366. So 2366x plus y. And I thought, maybe this isn't so bad. We've got the thing we want here. And let's see, over here on the other side, we also have to include this plus 1183 squared, and that's 4xy. So you go, wait, if I subtract 4xy, I'll get x minus y squared. And you go this way, you don't know it's going to work. You just keep going because you see things that you can do. And it's hard to let go of those things and go, well, maybe we should go back to the drawing board. That looks terrible. And so you kind of start thinking about it. How am I going to get this? I've got x minus y squared. If I would have had x plus y squared, and this and that, but not that, then it would have been good, but I do have that, and it's not so great, because I got to bring it over here, and now I have an x. So the idea would have been, if you consider x plus y as like v, then you would have v squared minus 2366. You're going to have a quadratic type form, plus this, and then, but the 4xy is a problem. So you go, you know what, maybe this isn't it. So you say, well, maybe I need to know like how to factor 1183. Like what goes into it? Let's go ahead and maybe prime factor. Maybe something can come outside and it'll give us a clue. We don't know. So it looks terrible, but does 2 go in? No. Does 3 go in? 11 plus 2 is 13. That's the sum of the digits. That's not divisible by 3. 3 doesn't go in. It's not a 5 that it ends in or a 0, so 5 doesn't go in. The first number you would really try is 7. So I'll do that now. I happen to know you have 700, and then you could do 350, which is going to be 1,050. So you're at that one. Maybe we should do something different. I'm thinking like 7 times 14, 140 would be 980. I don't know. It's a bunch of stuff you could choose. We're at 1,050 right now. Let's add 140 or just 70. Let's do 70. So now you're at what? 1,120, and you're 63 away. So 7's just going to go in. You're going to go in 100 times. You're going to go in 50 times. You're going to go in 10 times, and you're going to go in 9 times. 169. That's 13 squared. So then you've got 7 times 13 squared, and you're going to break out that 13 because that's why we started this, to see what we could discover. And you're going to get root x plus root y equals 13 root 7. Interesting. So wait a minute, let's go back. Positive integers. When you saw that, you should think maybe I'm doing number theory, Diophantine equations, things like that. You kind of want to have an idea of what the end game might look like because we're kind of getting there now. So I've got integers, but I've got to add these two things and end up with root 7. Could I add random roots like root 5 plus root 11 or something, and it somehow creates a root 7? I don't think that's going to work. Most likely, these both have to be root 7 some kind with a perfect square maybe. So how would that work? Maybe if root x ended up being equal to, what are we trying to do? The minimum possible, there's that min-maxing optimization thing, minimum possible value of x plus y, which would also be the minimum possible value of root x plus root y. So as long as we can minimize the square root values, then we'll do the same thing. So the idea would be, if I made this 6 root 7 and 7 root 7, because those are closest together, versus 8 root 7 and 5 root 7. We'll check that out too, just to be safe. But if I square both sides of this right now, you're going to get 36 times 7 plus 49 times 7. That will be your x. Actual x value is this. This is x. X equals that. That one's y, because you squared both sides to get them. And so you would say, okay, well then what's x plus y? It would be 85 times 7, which is 560, and 35, 595. We found that, but because there's something smaller, I feel we should just be safe and go pick something over here. If you did it here, 64 plus 25 times 7 would be 89 times 7, which is obviously more than 85 times 7. I bet it's this one right here, 89 times 7, and 7 times 90 minus 1. 7 times 90 would be 630 minus 7. Yeah, so real quick. 7 times 90 minus 1. 630 minus 7 is 623, exactly as expected. So then we say, well, could I do something like a fraction, like 6.5 root 7? And does it say they're different? If I squared a fraction, could I get an integer? Because this is lurking over here and it's just sitting there going, hey, are you sure it's this one? Because how prone have you been to mistakes in the past with false assumptions? So you kind of got to really make sure there's nothing else you could do. Fractions, 6.5 squared, not going to work. You're going to get like, I don't even know what that is. It's 42.25. So 6.5 squared, 42.25, even if they were right in the middle, and you could add 42.25 root 7, and you're going to double that, you would end up at 84.5 root 7, and actually it would be times 7, sorry, not root 7 anymore, because you squared it. So it would be 84.5 times 7, and if you just said, well, if I do 85 times 7, I'm here, I'm only losing 1/2, which would be 3.5. The lowest I could get, even if this was allowed, and it's not allowed because they're not integers, but even if it was allowed, you would only drop 3.5 from 5. You're not going to get here. That's the answer, and you can feel a little bit more comfortable with it by challenging your thinking and trying to find some way to get a little bit better assurance. I prefer to check my answers as I go. I don't like to come back at the end of the test with 5 minutes and try to figure out, okay, where was I at in my thinking process? That's gone. It's zipped off because you're doing other problems. Better to kind of feel better about your answer now, especially if it doesn't take that long to just explore a little bit longer to get better certainty. Let's get to problem 14. And here we get another small notebook concept appearing on the test. So if you were in that class, I really hope you caught this and were able to put it to use immediately. It's just a diamond graph. A dartboard is the region B in the coordinate plane consisting of points x, y, such that this expression, absolute value of x plus absolute value of y, is less than or equal to 8. If you took my class, this is a diamond graph whenever you have this, and the distance from the origin on the axes is 8. Let's go ahead and graph that. So you're going to go over here, you'll go up to 8, negative 8, 8, negative 8, and it's going to go like this. Now, you're inside of that region less than or equal to, so it'll be inside of there. There's 8 and 8 and negative 8 and negative 8 here. Okay, now a target T is the region where this is true. Notice it's something squared and you got a perfect square. You're probably square rooting. A dart is thrown and lands at a random point in B. The probability that the dart lands in T, this region, can be expressed as. Stop there, go find T. Okay, so now you're going to square root. When you square root a perfect square, you get the absolute value of that thing. Earlier in this test, we did cover the absolute value aspect, that if x is less than c, it simply becomes less than c and greater than negative c. So because of that, you can blaze through this. You're going to square root both sides. It's going to be 7 and negative 7. You're going to get x squared. That's small notebook concept as well. X squared plus y squared less than or equal to. It's minus 25, but you're going to have 7, right? So this will be a 7, and you're going to be adding 25 to it. You're going to get 32, and over here it would have been negative 7, and you're going to be adding 25 to that, so you get 18. When you're trained, you can just go straight to there from that point because you recognize what is happening. All right, so now a dart is thrown and lands random point, blah, blah, blah. We want to know the area of this region. Well, that looks an awful lot like a circle. X squared plus y squared equals. What does the less than do as an effect? It means you're going to be inside of the circle, whereas for this one, you're going to be outside of the circle. So what we're looking at is concentric circles. They're both centered on the origin. One of them has a radius of 4 root 2. The other one has a radius of 3 root 2. But we actually don't really care. We don't care what the radius is. Well, we take back. We actually do care. Because the outer radius, 4 root 2, is going to be this right here when you go perpendicular to that. So since this is 8, that's 4 rad 2, which means your outer circle does fit inside the diamond graph. I thought we wouldn't care, but we probably should care and check to be certain. So that's your outer circle, and then the inner circle here would go whatever, 3 root 2, something like that. That is the area it wants, the donut region. So how would we get that? It's simply pi big R squared minus pi little r squared. You factor out the pi. What's capital R squared and little r squared? They're these things right here. 32 minus 18 is 14. And you're going to have that over the area of the grid over here. It's just 8 root 2 and 8 root 2. So 64 times 2, 128. You could do that, or you could just do 64 times 2. We put 2 into 14 to get 7. 2 into 14 to get, hold on, so is it 14? 32 minus 18, 14 to get 7, and 7 over 64 is going to be 7 over 64 pi. Now, just really quick, we also could have said 8 times 8 is 64 over 2 is 32, and you would have 32, 32, 32, 32, 432 is 128. Just double checking you're not making any silly error or anything like that. 7 plus 64, is that what it wants? M over n pi, that's what we have, where m and n are relatively prime. That means they have no common factors. It does not mean they're prime. Very common language. If you're new to the test, learn it. Positive integers. What is 7 plus 64? Answer 71. Let's get to the next one. And the last video in 2 different rapid fires, one for the 10B problem 15, the other for the 12B problem 10. This question, it ended up being quite a bit of a time sink for me because I failed to catch certain pieces of reasoning that I had to go back and revisit and then caught. So if you had a significant time drain on this problem, you're not the only one. I did as well. And it's just going to depend how many of your contemporaries didn't have that trouble and reasoned correctly on it right away. If you were on the 10B, by the time you got to problem 15, you're probably pretty fatigued. If you're on the 12B, you're probably still a little bit fresh and you might have worked through it a little bit more effectively. So a list of 9 real numbers consists of 1, 2.2, these, count them, 1, 2, 3, 4, 5, 6 numbers, as well as x, y, and z, that's 9 total, with x less than or equal to y less than or equal to z. The range of the list, which is the difference between the greatest and the least, is 7. This plays a significant role in that reasoning, and if you manage to apply it correctly, it probably didn't take you as long as it took some other people who got lost in a couple of the details. And the mean and the median, the average and the middle number, are both positive integers. Because you have 9, it will be one number only. How many ordered triples x, y, z are possible? So your attack point should really be here. And the reason I say that, basically if z is the largest number, is how you want to start, then if z is the largest number, our current range is only 6. We're going to need z to be 8 if z is the largest. So we say, okay, let's say I've got all of this. In fact, let's add up what we have right now. 8, and then you've got 11, and 3 and 2 is 16.8. So all your 0.2s make a 0.8. I don't add things in conventional ways. I just do it as 2, 3, 5, 10, 16, 0.2, 0.2, 0.2, 0.2, 16.8. 8 plus 16.8. Those are your default numbers. You have a total of 24.8 with them. Now, if we add the z value as 8, so I'm going to have to write these, aren't I, to kind of keep track of what's going on. 2.2, 3.2, 5.2. By the way, the next number needs to be your median, which means it's either x or it's y. And so we're going to have to leave a space open for that because we've got 4 numbers right now. Who knows what it will be just. It's going to have to be 6. Whether it's x or y, we're not quite sure at just the moment. And you're going to have 6.2, and you'll have 7, and then you'll have 8. So this is either x or y. We'll figure it out in a moment which one it is. So now we add the z8. You're at 32.8. You know one of them is 6. That puts you at 38.8. And we have to add either x, just call it x for now, or it doesn't really matter, variable's fine, divided by 9, that's the mean, and it has to be an integer. Why does that 6 have to be there? Because the median has to be an integer, and our current median is this 6.2, which is not an integer. So something's going to have to go right here to become the median. So then what's this sum going to have to be? It's going to have to add up to 45, right? Could x be negative? And this is where if you weren't thinking about the range, you might have thought, well, what if x was negative 2.8? And the first thing you look at is right here, list of 9. Oh, real. Oh, they can be negative. And then you might mess around with that for a while and lose some time before you realize that even if 7 was the largest number, not z at 8, the lowest anything could get is 0. So your negatives can be dismissed immediately. That's a significant conclusion that you wanted to reach, and whether you caught it at the time you were supposed to or not, or it took you a while to realize it, determines how much time we spent or wasted on this problem. So now what? What does it have to be? It has to be able to get up to 45. So you are 6.2 away. Obviously, x would not be the value here. This would be y instead. This would be x on the 6 because y has to be greater than or equal to x. So that makes y 6.2. And so you would have x6, y6.2, z8. We found our first ordered triple solution. Okay, so now what? Okay, did everything get forced after we made this z8? What if could I put the y as the 6 instead and make, no, because there's no way to make this number get lower. It can only go up, and you have to have 6.2 to get there, or you're not going to reach 45. Could it get even higher to 54? No, that would make the other number go over z, and then z would not be the largest number, which it says it has to be in relative to the 3 unknowns. Okay, so what does that mean? It means once z is 8, x is forced to be 6, and y is forced to be 6.2. So the next thing that you would be, okay, what happens if z is not 8? And so you say, okay, maybe then, well, what if we focused on the median? If I make the median between the 5.2 and the 6.2, the only option is 6, and that ends up forcing, that's going to end up forcing the 8 and 6.2 choice as well. So what if now instead we moved x and y over to this side of that line, then y would now become the median, and x would be something less than or equal to y. So could we make y equal to 5? That's the next question we're going to ask. This is kind of like casework, and so we're going to make maybe casework based on what the median is. So if I have 1, 2.2, 3.2, and we're going to make y here at 5, x just has to be less than 5. We don't know what yet. So it's kind of a stipulation. You want to write down less than or equal to 5. We'll just put the x here for now, but it might actually be on the other side of this. If we do that, and you've got 5.2 after 6.27, you don't know, this is why, you don't know exactly where z is. And you don't know quite where x is, so let's just add up what we have. We have our default 24.8. We add y to get 29.8, because y is 5 in this case. This is the y equals 5 case. We'll also try if y equals 4, and we might get multiple values, multiple solutions when y is 5 or 4. We don't know yet. We haven't seen the future. So then you're going to say, okay, well, I'd have to get to 36 right now. 27 is not possible. I can't have negatives. The lowest anything can get is 0 regardless. So what if I said, okay, well, I need to get to 36. How far away is that? It's going to be 0.2 to 30 and then 6 more. It's 6.2 away. So could I make 6.2 z? because y can't be past the 5. So if I made another 6.2 here, then what would that mean? That means I'm at 36, but I still have to deal with x. It can get as low as 0. Since z is not playing the role of 8, 7 could be the largest, and then 0 would go here and be the x value. So it wasn't actually over there. And you might double check your calculation. I will not do that right now. 35 and that 36, we're going to have a mean that's an integer, and our median, which is y, is also an integer. You're just double checking, did I do everything? There's a lot of that, being careful on this problem as well, which also drains your time. So now what? We've got 0, and then y was 5, and z was 6.2. So now what I want to know is, once the y was 5, this was kind of forced, right? I can't get to 45. It'd be way too big. I wouldn't have a range of 7 anymore. But still ask the question. Make sure you justify why you're not doing that. Okay, so that means once you had this, that's the only solution when the median is 5. So let's go ahead and pick out a median of 4 now. If I do 0, all the same things, right? You're going to have, I'm not going to write them all. I wouldn't write them on my actual test, but for your sake right now, to follow my train of thought, I will. 3.2, you've got 4. And again, x needs to be on that side somewhere. That's y. And then you have 5.2, 6.2. And so you start to see that the real target should be the median for your casework. When the median is blank, 6, when the median is 4, and when the median is 5. And so now what happens? Well, think about it. Where we were just at, the only thing we changed is y to lower it to a 4. So this 29.8 that I was at will now go to 28.8 because you just lowered your y value by 1. Those kinds of thoughts save you time. And so you want to make sure you're trying to think about those kinds of things as you're working. I still need to get up to 35, which means, oh, was it not 6.2? Oh, 36 rather, not 35. 36. So I have to add 7.2, but I don't know what my z is and I don't know what my x is. Is this possible? And so you say, all right, well, let's say, can x plus z equal 7.2? Well, wouldn't x have to be 0? And this is where you could get yourself trapped. You could end up with a false answer. You say, well, x has to be 0 because the largest is 7, but that means z is on the other side at 7.2 now, and my range isn't 7. How do I fix that? Oh, well, what if I just made z minus x equal to 7? So if I say like z minus x is 7, the range, because making z the largest, then I could replace z with x plus 7. So 2x plus 7 equals 7.2, and that tells you x is 0.1. Now, I didn't do this math on mine. I just looked at it and said, well, I don't know, it just came to me. I just said 0.1 and 7.1 would do it, wouldn't it? And then that made sense. 7.1 minus 0.1 was 7. 7.1 is the largest. You got to keep checking all the little things that could trip you up and get it wrong. And so that's going to move you from the trap answer, kind of a trap answer of 2, to the real answer of 3. Now you still kind of want to go back and ask, is there anything else I could have done? Could the median be less than 4, like say 3? No, there's no way I can put x and y here. Well, now we have to wonder. Let's go ahead and check. What if I put z as 3? And then, yeah, let's check that really quick. What if z played the role of 3 out of curiosity? You can't get lower than 0. What would that do? That would take this 28.8. You're lowering the total by 1. You're down to 27.8. And you would need x plus y, because they have to be lower than z. You're going to need that to equal, to get to 36, you were adding 7.2. Now we have to add 8.2. The problem, even if they're both 4.1, they're both bigger than 3. Now you say, well, why couldn't y be 3? because we only have 2 values at the start, and the 5th value is the median. So if I tried to produce a 3 right here, I'd have to have all 3 x, y, and z be less than or equal to 3. And further, this is just past 27, so there's no way I could choose 0 for both of them either. You're going to be trapped. This is good. It makes you think, but the actual answer will be C. Hope you enjoyed it. See you in the next one.